Okay, welcome back, Planet Numeracy fans. This is Mr. Nolde again, here to teach you just a quick problem on how to solve coin problems using simultaneous equations. So I'll show you how to do this one two ways. One using substitution and one using elimination, since two of my recent videos were on those. So this problem says that Ruby and James have 28 coins that are nickels and dimes. If the value of the coins is $1.98, how many of each do they have? So the thing you're looking for in these problems, two things. You're always going to be looking for, number one, a quantity. Okay, a statement about quantity. In this case, says they have 28 coins. You're also going to be looking for a statement about value. So when you do these types of problems, quantity and value. So value of $1.95. So I have nickels and dimes, total of 28, and their value is $1.95. So one of the ways you could set this up is just say, well, I'm going to let n equal the number of dimes, or I'm sorry, let's let n equal the number of nickels, how about? And d is going to be the number of dimes. So the number of nickels plus the number of dimes is 28, and that's the 28 in this problem. So that's my quantity statement. That takes care of the quantity statement. We also have a value statement. It says that they're worth $1.95. So two things you have to remember to do here. Number one, 5 cents per nickel plus 10 cents per dime equals, okay, because it's 5 cents per nickel, 10 cents per dime, but how many cents is $1.95? So if you don't want to mess around with decimals, I suggest making this just 195. So that equals 195. All right, so here's equation one. Here's equation two. Let's first look at it by doing substitution. So it doesn't matter what we do. I could solve for n in the first equation in terms of d, or d in terms of n. Probably wouldn't want to solve this for n. I could solve this for n because 10 is divisible by 5 and 195 is divisible by 5. But if I tried to solve this for d, I'm looking at a half, 5/10 is a half, and 195 is not evenly divisible by 10. So let's solve the first one, just for no other reason, just to say n. All right, so n would equal 28 minus d. So you subtract d on each side. Now go back to equation 2. And every place that you see an n in equation 2, substitute 28 minus d. So here we go. 5 times 28 minus d plus 10d equals 195. So now we have an equation that has only d's in it. So I have a d here and I have a d here. So let's distribute this 5. So that's what I'll do first. Let's see, 5 times 28, that's 100 plus 40. 140 minus 5d plus 10d, and still equal to 195. All right, next, we'll scooch up a little. Let's combine our like terms. Okay, got like terms here. So I'd have 140 plus 5d. That's equal to 195. Isolate your variable term, just like always. Subtracting 140, let's see, 140 from 195. That gives us what? 55. So when I divide both sides by 5, divide this by 5, divide this by 5, your final equivalent equation is your solution for the number of dimes. Okay, so now we know that the number of dimes is 11. So I could do mental math, or I could come back up here to equation number 1 and say, all right, let's go ahead and substitute my 11 from down here in place up here. So I just took my 11 and I substituted it in place of D. So now I know that there are 28 minus 11, or 17 nickels. So 17 nickels, that's my pointer, 17 nickels plus 11 dimes. That gives us 28 coins. And if you figure that out, 5 times 11 is 55 cents. 5 times 17, that would be the balance. 5 times 17. Oops, I did that wrong. 10 cents, that would be $1.10. And 17 times a nickel, that would be 85. So $1.10 and 85 gives us 195. So that checks. So let me just show you real quick one other way to do this. And a lot of students would prefer this. Instead of using substitution, taking and using, let me rewrite those equations over here. And we'll even switch colors for you. N plus D was 28 coins, and 5N plus 10D was 195 cents. All right, so notice here, still, you don't put 1.95 unless you have 0.10 and 0.05 here. So we don't want to do that. So here's my system. I have equation 1, equation 2. I'm going to take equation 1 and say multiply it by 5. Actually, a negative 5. So if I multiply 5, negative 5 times n, I get negative, my pointer's being finicky here, negative 5n. And then if I multiply it up here by negative 5, I get negative 5d. And then multiply 28 times negative 5. 28 right here times negative 5, that would give me negative 140. So now I would like to add these equations together. That is why we wanted to make this guy be the opposite of this guy. So 5 and negative 5, those add off. So that's what we wanted to do. We wanted to use elimination and eliminate the n's. So when I add my d's, let's say I get 10d minus 5d is 5d. And 195 minus 140 is 55. So notice we're ending up with the same equation that we did when we did substitution. We're just getting there, I think, a little bit quicker. So d is equal to 11. And then same thing, I could bring this 11 back up here to the first equation and say, all right, I've got n plus 11 equals 28. Solving for n, 28 minus 11 is 17. So you still get the same, I still get the same answer. Okay, same thing, same problem even. I did 28 minus 11 equals 17. That looks like a decimal. So I could use either one of these. It really comes down to a matter of personal preference. For the coin problems, I personally prefer doing this, using the elimination method, because notice you write your system down, multiply, add, solve, and solve. There are fewer steps, it seems to me. Maybe 2 fewer steps, but the shortest algorithm is the best algorithm. So thanks a lot for paying attention to this. Make sure you indicate down in the comments below if there are any other coin problems or any other problems, like say with adult tickets and student tickets, that you would like to see me do, because I could definitely throw some of those on here as well. So until the next time, please hit the like button. It helps the algorithm, and consider subscribing.